Hi, this is Anirudh, and in today's video we'll be solving questions of advanced resistances as a part of current electricity. Please do follow us on our Facebook, Instagram and Telegram channels for your daily dose of math and physics. Let's get started with our JEE problems. For the first sum today, we need to find the resistance of this structure over here whose resistivity has been given as rho, and you need to find it about these 2 points. Now the thing about this structure is that it's not a continuous smooth wire, it's a wire with varying cross-sectional area. So first step in this process is to find the radius at any one point. So suppose if we take the entire length as we consider it varying with x, we need to find how the radius varies with x. So suppose this point is at x equal to 0 and this point becomes x equal to L. So I know the radius at this point is A, at this point is B. So the radius we can find using our equation for a straight line formula, which says that y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. So we put y1, x1 values. y1 means A and x1 is 0 and y2 is B and x2 is this. So we get y minus A is equal to B minus A divided by L into x, or the y is equal to B minus A by L into x plus A. This y is your radius r at any one point over here at a distance of x. So since it is variable, we need to use integration for the method. The way we integrate is we consider a thin strip of thickness dx placed at a distance x from the initial point. We need to find what the resistance of this single strip is. So the resistance of that single strip is given by rho L by A. The length is dx, so rho dx divided by the area would be the cross-sectional area, that is pi r square. We just found the value of r at a particular x, so we can put that in here. So that gives us rho dx divided by pi b minus A by L into x plus A whole square, because it's pi r square. Now this is of a single strip. You'll have one after the other consecutive strips following each other, and to find the total resistance you need to integrate all of them, because these all strips are in series connection. So the total resistance becomes integration of this rho dx by pi b minus A by L into x plus A whole square. The limit ranges from x equal to 0 to x equal to L. We use the substitution method here. We consider a certain y is equal to b minus A by L into x plus A, so that we get dy is equal to b minus A by L into dx, or dx is equal to L dy by b minus A. We replace that in here, so our resistance now becomes rho L dy divided by b minus A into pi, and this entire term drops down to y square. We also need to find the limits of y. To do that, let's put the values of 0 and L at the 2 points. If x is equal to 0, then y is equal to A, and if x is equal to L, then y is equal to B. So y ranges from A to B. And now the resistance we can find, integrate this easily. All these terms over here are constant, so they come out. And we integrate just dy by y square, which gives us minus 1 by y with limits from a to b. If we put the values in, let's separate out the calculation part. We put the values in, that gives us rho L by B minus A into 1 by A minus 1 by B. There's also pi here. You do basic reciprocal addition, so this gives you B minus A by AB. So rho L by pi B minus A into B minus A divided by AB. These cancel out and your final resistance comes to be rho L divided by pi AB. That is your option number C. In the third sum, we'll be doing a similar thing with parallel, so stick for that. So this is a question that came in the JEE Advanced of 2012. So let's test it out. You need to check out all these options inside this circuit over here. Now it says that the first option, that the current through PQ is 0. Now this gives us the way to solve this sum as a whole. Let's in the beginning assume that the current through PQ is 0. If the current through PQ is 0, we find that the current through RS will also be 0. Because you have a 2 by 4 half and you have a 2 plus 2 4 and a 4 plus 4 8, that is a 4 by 8 also half. So this part of the circuit and this part of the circuit forms a balanced Wheatstone, so no current flows through this. Now that we have found that no current flows through this, let's cover this up and let's try it out for this part of the circuit. Again, you have a 2 by 4 and you have a 4 by 8, that is half. So even this wire, this 1 ohm over here, is across a balanced Wheatstone. So you see that no current passes through this, but that was also our initial assumption. Hence, we can deduce that our assumption was correct and no current flows through either this or this wire. That means these two come across both balanced Wheatstone bridges. So first option comes out to be correct. Next, what we need to do is we need to find out whether I1 is equal to 3 ampere. As soon as we deduce that no current flows through this, the circuit simplifies and becomes something like this. You have a 2 ohm, another 2 ohm and another 2 ohm over here, and this side you have a 4 ohm, another 4 ohm and another 4 ohm on this side. That is connected across a 12 volts battery. Let's put the values in. This is 2, 2, 2, 4, 4 and 4 over here. I need to find this current I1 and I also need to find this current out here I2. To find I1, I need to find the equivalent resistance of this entire combination. You have 2 resistances in parallel, so the equivalent resistance of this in series is 6 ohm and of this in series is 12 ohm, 4 plus 4 plus 4. So in parallel, the equivalent resistance would just be 6 ohm from the top wire into 12 divided by 6 plus 12. That would give you a 72 divided by 18 ohms, that is 4 ohms. So the equivalent resistance of this entire combination is 4 ohms. We can find the I1 current directly now. I1 is equal to V by R equivalent. V is 12 volts divided by the R equivalent is 4. So that gives me 3 amperes as I1. So my second option is correct as well. Before we go to the third option, let's go to the fourth option. I need to find I2. I can use the branching currents formula over here, that the current through one of the branches is equal to the resistance of the other branch, that is 12 in this case, divided by the sum of the resistances of the parallels, so 12 plus 6, into the main current that flows, or the total current that comes in, that is 3 amperes. 12 by 18 would be giving you a 2 by 3, and I2 would come out to be 2 amperes. So even our fourth option is correct. Now for the third option, we also need to find the current through the other branch over here. Let's call this I3. If I2 is 2 ampere, then I3 has to be equal to 1 ampere. So the potential drop across this is point Q and this is my point S. Potential drop across this region is equal to I2 into the resistance 4 ohms. So the V is equal to 2 into 4, that is 8 volts. This is Vs, and your VQ is equal to The resistance is still 4 ohms, but the current here is only 1 ampere, so 1 into 4, that is 4 volts. So there's a greater potential drop across S than across Q. So the potential at S is less than the potential at Q. So even our third option is correct. Let's go ahead and move to the next one. This sum is similar to the first one, but in the first one you had a structure where the cross-sectional area was changing, that is your A was changing. In this the L is changing because the length of the inner side is much smaller as compared to the length of the outer side. So since it is varying, that is why we have to again use integration. Let's go ahead and see how we can do that. So the initial thing is to consider any one point, a thin strip of thickness dx placed at a distance x from the center of whichever circle this completes. So this is a quarter circle. So you'll have the same dx in here, and these will together form a strip. You'll be getting a strip of wire. Now we need to first find the resistance of this thin single strip. The resistance is equal to, okay, before that let's find the area. The area of this is equal to h into the thickness dx. So h dx, length into breadth. And the next we need to find the length of this. The length will be equal to 2 pi x divided by 4, because this is a complete circle of radius x and you take a quarter of that. So the perimeter of the complete circle by 4, that gives you pi x divided by 2. Now we can find the resistance of the strip. Resistance of the strip is given by rho L by A. Putting the values as we just found, rho pi x divided by 2h dx. Now the first issue we notice here is that the dx comes in the reciprocal part. But we have to see that this strip and the strip next to it and all the strips that you can form on this, all of these would be connected in parallel, not in series, because each of the strips would be connected across the same two ends. So we have to find the equivalent resistance in terms of parallel, and as we know, the parallels add up reciprocally. So you have actually the integration of the reciprocals of the strips. So let's put it in. The reciprocal of the strips would give you 2h dx divided by a rho pi x. The limits of x go from a to b. Putting that in, you have a 2h and a rho pi as constants, so you can take them out. Rho 2h by rho pi, integration dx by x from a to b. Integrating dx by x gives you an ln, that is a natural log. So 2h by rho pi ln of x across the limits of a to b, 2h by rho pi ln of b minus ln of a. Ln, the logarithms, when you subtract, they go under division. So you have 2h by rho pi ln of b by a. But the thing to notice here is this is reciprocal of the equivalent resistance. So to find the actual equivalent resistance, we just need to turn this over. So we get that the R equivalent, the equivalent resistance, is rho pi divided by 2h ln of b by a. That is our fourth option. So these questions are very important for JEE, especially these variable combinations and learning how to use integration. That's all we have for today. I'll see you again in the next video. Like, comment and subscribe to our YouTube channel Mathophy for your daily dose of math and physics.